Okay, today we're going to have a little look at a flowchart, and we're going to do a trace table. We're going to produce a trace table based on this information that's in the flowchart. So the following, this is from a past paper, from an IB past paper. The following flowchart represents a standard algorithm. Okay, what we're going to do is copy and complete the table. Okay, I'm going to show you that in a moment. That traces the algorithm in the flowchart using an input value of 19. Okay, so we're going to input a number of 19, but I'm just going to draw my table out. Just going to my first number. My only data I'm going to put in, the only test data I've got for this particular table. So I've got number, I've got digit, and I have, this is Canva by the way. I've not used it before. Digit, and output. Okay. Can I draw a line? Is it going to let me draw a line? Okay, line. Okay, good. Okay, so I'm going to put the number 19 in here. Okay, so I've inputted the number 19, and then move on to this. Digit equals, digit in here, digit equals number mod 2. Okay, but what does that mean? Well, if I take the number 19 and I divide it by 2, on this side, I've got my divisor, and that's 2. Okay, but on this side, I've got what I call my quotient. Okay, how many times does 2 go into 19? Well, it goes in 9 times. Okay, and then there's going to be a remainder of 1. Yeah, so we've got the end result for this would be 9. And don't think about 9, okay, it's 9.5. But in terms of modulus 2, we're looking for the remainder. So it would be 9, remainder 1. Okay, so the digit in this case would be, the 1. So if I just swap the pen back, okay, I've got my digit would be 1. Yeah, I'll put the digit, okay, and then the next number value, yeah, number equals number divided by 2, okay, would be 9, okay, would be 9. You see that? So input the number 19, the digit equals a number divided by modulus 2, what would be the remainder, okay, if we divided this number by 2, the remainder would be 1, we output that digit, yeah, and then number equals number divided by 2. Well, number divided by 2 is 9. Okay, so 9 goes in there. Is the number equal to 1? Well, 9 does not equal 1, so we go back up. So I've put 9 in there, okay, and then I've got 9 divided by 2, okay, which of course, how many, if I do this side, okay, I've got 2, yeah, 2 4s equal 8, yeah, with a remainder of 1. Okay, so I've got 4, remainder 1. So this one, the digit would be 1 again. My output would be 1. Yeah, but my dividing 9 by 2, I would end up with the number 4. Okay, now we've got an even number. Okay, we've got 2 odd numbers there, we've got an even number. So let's have a little look what an even number would do. So I take the, does it equal 1? It doesn't, it's 4. So I move it back, digit equals number mod 2. So if I divide 4 by 2, obviously I get 2, remainder nothing. So I've got zeros, and I've got 2. Does the number 2 equal 1? No, it doesn't. So we'll go back in, 2, let's put this up here, 2 divided by 2 equals 1, remainder It's again, it's an even number. So I'm going to put in here 0, 0. My output would be 1. Okay, so here we go. Input number, digit equals mod 2. Output digit, number equals number divided by 2, but the number equals 1. So does the number equal 1? Yes, it does. So I'm going to output the number 1. So that would be the end, yeah, of that. Now, one thing that might occur, and what usually does occur, is, okay, we've done this, we've got this number, but what on earth does that number mean? So we look at it and we think, okay, we've got 1, a 1, a 1. So it looks like we've got a binary value in the digit, we've got a binary value in the output. So I'm looking at this and thinking, okay, we normally, when we do a register, we do it in reverse order. So if let's change the color of this to green. If I go 1, 2, 4, 8, 16, and now it wants to just draw lines. If I take this into account, I've got 1, 0, 0, 1, 1. Okay, so I've got one lot of 16. So I've got 16 plus 2 plus 1 equals, equals 19. So I've done a reverse. I've taken 19, I've turned it into a reverse binary number. So what is it doing? It's giving me a binary. This here is giving me a binary representation. So it's created a binary representation of the number 19. To test this, and I recommend testing it, I'm just going to see if this works. Let's try and rub some of this out. And I'm going to put a new number in. 29. Okay, we'll start again with an odd number. 29. So put the number in. 29. Okay, input the number, divided by 2. Okay, what do I get left over? Well, 14. Okay, 14, remainder 1. Okay, so I put 14 in there. I put my 1s in here. Okay, now I've got an even number. So I'm expected to put zeros in here. So again, 14, we've gone through it. 14 divided by 2 equals 7. Okay, so I can 0, 0 that, pop a 7 in there. 7 divided by 2. Okay, we're going to get 3, remainder 1. So put my 1s in, pop my 3 in. Okay, so 3 divided by 2 equals 1, remainder 1. So put my 1s in, pop my 1 in there. Does the number equal 1? Yes, it does. Output 1. Okay, so I've got a series of odd and an even number in there. I've got 1, 1, 1, 0, 1. So let's plug that into this. I've got change the colour so you can see it. Okay, I've got one lot of 16, one lot of 8, one lot of 4, no 2s, and a 1. 16 plus 4 is 20, plus 8 is 28, plus the 1 would give me 29. So this little algorithm here shows me that if I take any number and push it through this and repeat the process, basically keep dividing everything by 2 and look for the remainders are either going to be a 1 or a 0, based on it being an odd number or an even number. I'm going to get this here. And it's quite clever, isn't it? I'm going to get this here, which gives me a reverse binary representation, of the value. So I'm turning the denary number into a binary number. Okay, that's it for that one. Okay, I hope you followed that through. That's how I would do that particular task. When an exam paper asks one of these particular questions, it will be why. Okay, what is it? How do you run the trace through it? It might be more than one number. Okay, usually is more than one number. This occasion it just starts with one odd number. But run the trace through it. Okay, what do you think the algorithm, the flowchart represents? Okay, that's it for that one. I will be doing some more over the course of the next few weeks. Okay, thank you very much indeed for watching. Bye for now.
Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.